Okay. All right. Everybody see my screen?
Yes.
Okay. So I'm going to show off our AI-driven infrastructure workflow that we've been working on here over at HashiCorp. This is an opinionated, spec-driven development workflow within an AI coding assistant that leverages spec-driven development. So we're going to produce our specifications and our designs before actually performing the implementation. And it also leverages a GitOps workflow where a Git issue will be opened against the source repository where our Terraform module will live, and the agent will work against that Git issue and produce a feature branch for our work that we want to implement. Let's get this ready. So a little bit about the workflow. There are two main phases during this workflow. If you go to tfai.vercel.app, you can see this little representation of the workflow that we've put together. It starts with a TF plan command that you're going to send to your coding assistant, and that's going to walk through the creation of the specification artifacts. It's going to perform research using both our Terraform MCP server, and in this particular example that we're going to go walk through, the AWS Knowledge MCP server that's used to pull down best practices from AWS itself. That's going to inform that's going to give the agent more context about the best practices around AWS. And then we're going to step into the TF implement skill, which is going to run the back half of the workflow, and that's going to take the artifacts that were produced during the TF plan workflow and actually implement the Terraform module itself in our repository. So I've got our repository over here. This has a representative setup for a Terraform module with no content in it. And it has the necessary primitives loaded in it for Claude Code, Copilot, and others. We're adding other supported assistants to this repository as we work on this. So what I'm going to do here is just launch my coding assistant, which for right now is Claude. And we are going to start off with our TF plan workflow here. So this is a Claude skill or an agent skill that's loaded into Claude Code. And what it's going to do is it's going to work with me, the user, to create specifications for new Terraform resources that I want to build as part of this module. So if I were to launch this just right now, it would start running, and it would start asking me questions about what we want to build. But I'm going to go ahead and give it some information here to let it know what I want to build. So I'm going to say I want to set up an S3 bucket to store static content. I want to create a CloudFront distribution using an origin access identity so that the bucket isn't publicly exposed. And I want to enable CloudWatch metrics and alarms to monitor usage and basic health. Add a simple static test page, and this is for validation only. So I'm giving it a little bit of information about what I want to build. So we're going to step into the TF plan skill here. And Claude's going to get running. It's going to start thinking, and it's going to start using the skill definition to run a multi-phase workflow. It's going to first validate our environment, and this is just a script that it's going to run. And then it's going to use our Terraform MCP server to list all the Terraform organizations which my user has access to. I'm going to select, it's going to use this Ask User Question tool to present this nice little user interface where Claude will work with me, the user, to ask questions to me where I can provide answers to. I'm going to select this organization. It's going to ask me what region I want to deploy these resources into, what AWS region. I'll select US East 1. Get that person in there. It's going to ask how autonomous I want to be with this spec-driven development workflow. And I'm going to hit fully autonomous, and then I'm going to submit. See here, it's going to work with my Git repository to figure out which remote Git we're operating against, and then it's going to launch its workflow. So you'll see first here, it's going to create a GitHub issue and a feature branch so that we're not working directly on main. And it's also going to do that GitOps workflow that I talked about at the beginning of this meeting, where it's going to open up an issue and work against that so that we have a record inside our remote repository of the work that's being performed and what output of that work was generated. All right, it's going to ask me whether I want to create this GitHub issue. You can see here it's just using bash to run the GitHub CLI, and it's going to create an issue. We've got a template for the issue so that all the issues look the same and have sort of the same structure about them. I'm going to tell it yes, it can do that. It wants to check out a feature branch. Yep, we can do that. And so this is just all information that's encoded into that skill that we've loaded into Claude Code. We've told it to perform this particular workflow, and we put that in the skill definition, and it's running through that skill to do that. So the first sort of spec-driven development workflow that it's going to engage in here is it's going to take our prompt that we gave it around creating an S3 bucket for serving a static website, and it's going to create specifications. So if you're familiar with spec-driven development in traditional software engineering, it's going to create user stories, and then it's going to tie those user stories to an actual checklist that it will use to perform the implementation later on once we get to the TF implement phase. So I'm going to click in here to this TF plan while this is running over here and show you a little bit more about how this is structured. So you can see we have a couple of different phases here. This one has 5 phases, but over here we have 6. We're still working on the actual structure of this. Let's see here. Get some more people in here. We're using agents, sub-agents, and skills to produce artifacts. As you can see over here, we're running through these phases, and during these phases, you'll see different sub-agents being used. Right now, we're in the spec-driven development specify sub-agent. It is creating our spec.md for the S3 bucket and the CloudFront distribution and the CloudWatch metrics and alarms. You'll see it's going to start writing our spec.md to this particular directory right here. And if we go ahead and take a look at this spec.md, you'll see that it has some information about when this was generated, some of the context around what this is, and our user stories here. So if you've ever been in like a UAT environment, in a traditional software engineering environment, you'll find these familiar. These are standard user stories with acceptance scenarios. And what our workflow is going to do is it's going to read these, and it's going to create a checklist such that the implementation of our actual Terraform code later on when we get to the TF implement phase follows these specifications and follows the checklist that's performed or that's generated later on during our during this run. So we're starting the spec-driven development checklist sub-agent right now. It's going to search for existing checklists which don't exist yet, and it's going to read the spec.md and generate implementation checklists from the specification. So we've got this specification. User story 1 is to serve static content securely via CDN. User story 2 is custom error page handling. And user story 3 is operational monitoring and alerting, so on and so forth. And this has formal specifications with feature requests in here, or functional requirements, I should say. The interesting part here is that we're going to take what was generated by Claude, this specification and the implementation checklist, and we're going to launch this spec-driven development clarify subagent. Now, this clarify subagent is sort of a watchdog. What it's going to do is it's going to look over these documents that were generated, and it's going to look for any ambiguity that's in there. And you can see it's editing these files as we're looking at them. It's looking at all of the functional requirements, the user stories, and where there's ambiguity, it's resolving that ambiguity in real time. And that just makes the output quality when we get to the TF implement phase that much better. So we'll let this keep running. It's updating our spec.md right now. We're in the clarify step of phase 2. So it's going through our spec.md, it's going through our checklist, and it's resolving any ambiguities. If it feels like it needs to ask me, the user, to answer any questions, if it doesn't have enough information from me to continue forward and continue resolving ambiguity, it will actually use that same ask user question tool that we saw at the beginning of the workflow to reach out to me and ask me questions and have me resolve any ambiguity that it can't resolve using the information that it already has. We may or might not see that when as we're working through this workflow. It's going to write this file clarifications.md, and these are the clarifications that it needed to perform and the resolutions that it applied. You can see that it didn't need to ask me any questions in this particular workflow. While this is running, I'm going to move over here to the actual remote repo that backs this repository that we're working in. And if we take a look at the issues page for this remote repo, we can see that we have the GitHub issue that it opened for us for this work. You can see it's applied some labels here for us: agent driven, Terraform. It uses that issue template that we saw earlier to create the issue. And here's some information about what the change that we're introducing is going to be: some success criteria, information about cost optimization, and information about how we configured the agent when we were working over here. If we go back over here and we take a look at Claude wants to run a tool from our Terraform MCP server. This Terraform MCP server is produced by us and has tools related to interacting with your HCP Terraform tenant, your SaaS tenant, so it can reach out to your actual HCP Terraform organization and see if you have any private modules in your private module registry that might be useful for implementing this work that we want to implement. So it's going to reach out to that. It's going to ask for my permission. I'm going to tell it yes. It's going to ask to use another tool, the provider document type. I'm sorry, this is the Get Provider Details tool. To identify the most relevant provider ID, we're going to give it permission to do all these things. And as you can see, we've moved into phase 3 here, research and planning. That's going to use parallel subagents to do research, and it's going to use that Terraform MCP server that I mentioned earlier, as well as the AWS Knowledge MCP server that we've configured. You can see those here in this .mcp.json. This is just running our Terraform MCP server and the remote AWS Knowledge MCP server. And it's going out and it's using those to perform research. It's saying, I want to take a look at your HCP Terraform tenant and see if you have any modules in your private module registry for working with AWS S3 or AWS CloudWatch or CloudFront. And then it will use those instead of public modules or writing its own code. And in that way, you can enforce organizational governance to have your modules in your private module registry and have your agentic workflows use those modules out of your private module registry instead of public modules. You can see that here, the agent has been updating our issue as it's been working. We're now in the research phase. All 3 research agents completed. There were some key findings. We do have an S3 module in our HCP Terraform organization. We also have a CloudFront and a CloudWatch module. All right, so it's using the spec-driven development plan draft sub-agent to create a draft plan from our specification and our research. So it's going to take these artifacts that it's already produced, and it's creating a draft plan. So we're giving it a specification of what we want to produce, and it's going out and doing that research to make sure that it's applying best practices and using the private modules that are in our private module registry, and then it's going to create that that draft implementation plan. And so all of these artifacts are about specifying the what and not the how to implement our Terraform module. Does anybody have any questions while this is running?
Yeah, Ram here. I kind of have first-hand experience with this. I tried the Copilot Claude with the module revamping, where we have the enterprise governed module within our environment, and then we were able to do it. Oh, the only difference that I see the agents here running, right? So I would also want to know what is the Claude skill that you talked about earlier, mentioned about, and then I have some other questions as well. I'll keep it to the last. So yeah,
Sure.
to start with the Claude skill.
Yeah. So this is a it's not something that we've publicly published. It's in this repository that I'm operating in. So that's how it has access to it. So if you're familiar with sort of how these coding agents load artifacts, they're either in the repository that you're working in, or they are in your user home folder. And the agents, wherever you launch them, will find those artifacts based on where you launch the agent. So I launched the agent right here in the same folder where this code base is. And you can see I have this .claude folder here.
Right.
Underneath it, I have the skills folder, and that's where we've defined all of our skills that we're using in this workflow. The one that I executed first was this TF plan skill, and it just has our workflow here.
So basically, you can say what exactly, I mean, like how exactly your code should look like. Like, let's say, according to our enterprise standards, that's where you write the skills or you write in the specs.
Yeah, I mean, you could put your coding standards in a skill and have the workflow skill call that skill from when it's executing. So you can apply your coding standards at that level, and then have this TF plan skill. It really defines a workflow, but you could also have a coding standard skill, and you could just ask the agent that's running the skill to call another skill when it's in flight to use your coding standard skill. You could also put it in this agents.md file here. Agents.md is used to provide instructions or rules to the agent when it's operating inside the code base. Generally, that's where I put my coding standards when I'm working with coding assistants. Is I'll put them in an agents.md or a claude.md, usually actually at the user level, because those are my coding standards. Now, if you have organizational coding standards, you would put them either in a skill that you could move around to individual repos, or just define them as a base layer agents.md that you put in every repo. All right, so it wants to run an echo command. We'll give it permission to do that. We're
So
still in this STD plan draft sub agent right now. So it's again it's going through all of our artifacts that were already generated, the specification, our research, and it's going through and creating our checklist, and it's going through and creating contracts related to module interfaces and the data model that we're going to use to pass information between the modules in our whenever we generate our actual Terraform code.
sorry again. The agents that we have running on our system on the Mac, let's say any developer can go ahead and change the standards. Is there any way that we can lock in such a way that it cannot divert, it is not diverging from the actual coding standard that is defined by the enterprise?
Yeah, it depends on what coding assistant you're using. So I'll give you the answer if you're using Claude because this is the one I'm most familiar with. If you're using Claude Code, there is enterprise governance where you can supply an agents.md that applies to every Claude Code instance which is logged in against your enterprise API key.
Got it.
And in that way, you can provide rules to every agent that's executing across your organization that must be followed. It must read those rules when it's generating code or performing any task.
Yeah,
that's really a function of what coding assistant you're using and what sort of enterprise governance capabilities it provides. If you want to implement it yourself, like roll your own, like I said, you could have like a template repository where you have an agents.md in that template repository that defines your coding standards, and then create your all your actual implementation repos from that template repo. But like you said, a developer could just modify the agents.md at that point on their own. So you really need to define it in some way that can't be modified by the end developer if you really want to apply like sort of strong governance rules around that.
Got it. So I know I'm going all over, but then yeah, there's too many things. Another question is that are you guys applying this towards your Terraform provider releases today in the backend, or?
This is more for this particular workflow is more for consumers of Terraform. This is going to be able to generate Terraform modules from if you are maintaining a Terraform, an HCP Terraform organization, and you're using the private module registry. This is more for that.
Got it. Yeah.
We are also working on workflows for Terraform module, like shared module development, so that you can create modules that are intended to be consumed by other modules. This is sort of the inverse of that, where we're reaching out to your Terraform organization using our Terraform MCP server to look at your private module registry and pull modules down. And then we're also working on workflows for creating Terraform providers. So if you have the need to create a Terraform provider that doesn't already exist, then we're working on workflows for that as well.
Right. So I had to ask this because we do some kind of enhancements, like periodically, right? So if they know what is happening in the Terraform provider, in that case, enhancing a module would be much easier. But so that was the question. So if agents know them, what is really happening from what is it trying to do a research from where exactly? So
yeah. So if you have any existing modules that that you need to enhance, this workflow would probably work. I think it's more suited to like net new modules as it stands. So you'd have to play around with it honestly to feel like to get a sense of whether it's going to work with a complex module that you already have in development. But because it does that research phase, and because all of these agents, they're extremely good at like reading and understanding your code base, especially nowadays with the newest models and the newest harnesses. They're very, very good at like understanding what you've already got in place. So if we were to do the same exact thing but with a module that we already had in place, Claude Code and Codex and VS Code Copilot, they're all like the system prompt of these harnesses is they're all told to like go out and explore the code base and make sure that you're not like clobbering work that's already in place. So I would expect that this workflow would work just fine for in place modifications of modules that already exist.
Sure.
All right, so
Thank you.
we've done our TF plan workflow. We've flowed through all the different phases. We've created our issue that we're working against. We've created our specification artifacts. We are on the feature branch that it created for this work. It's performed research, found 4 private modules in our organization. It's performed planning, where it created plan.md, data model, and module interfaces. And we've got 3 phases done and 12 architectural decisions in there. And it's performed our tasks phase, where it has outlined tasks and an analysis of what we want to go do when we move into the implementation. One of the things that is interesting about this particular workflow that we put together is that because we're reaching out to the AWS Knowledge MCP server, and that AWS Knowledge MCP server provides best practices for using AWS resources like CloudFront. We told it that we wanted to use, we told it to use Origin Access Identity. So it went out and it looked at the AWS Knowledge MCP server, and they actually want us to use OAC. But because we, the user, specified OAI, it's gonna work with us, the user, to do what we want. We found all the private modules from within our private module registry, and we're going to create one raw resource that is not aligned to a module in our private module registry. All right, so we will move forward. What I'm going to do here is I'm going to create a, because we have our, go ahead.
Quick thing, can you please click on that plan.md? Just want to see the content, how it shows up. Plan.md, yeah, thanks.
Right, so this is this was the document that was produced out of our planning phase. So it took our specifications, what we want to implement, and then it researched how to implement and propose this draft plan that that the TF implement skill that we're going to run through next will implement. So it gave us a some gates that we need to pass before we start our implementation. It gave us a module inventory, some module gaps, which we have none of, architectural decisions, proposed project structure, source code, structural decisions, and then it came up with a multi-phase implementation plan.
Okay. Do you also have like any guardrail setup here, either Sentinel or OPA?
Not at the moment. Not at the moment. Now, if the prompt that I sent to the agent, the original prompt mentioned setting up Sentinel policies or OPA policies, then the agent would have created those. But I didn't specify that I wanted those.
Okay, thanks. So I think this one is connecting to AWS. It is also connecting to Terraform Enterprise to fetch the private modules.
Correct.
From your machine, from where you are running right now.
From our organization. Yeah, if I go into here, this is the organization that I selected right at the top of the workflow. We have all of these modules. Here's the CloudFront module that it found, the CloudWatch module that it found. So it's going to prefer using modules out of your private module registry instead of either creating its own code or fetching public modules from the public module registry. And that's just instructions that we've provided to the workflow through the skill that we're running through. All right, so what I'm going to do here is I'm going to start a new, we're going to move back to this.
Thanks.
And we're going to move to the TF implement page here. And while you're looking at that, I'm going to start a new session. And then that's going to clear our context window on our agent. It's just going to make sure that we have a fresh context window for our actual implementation. So we're going to do the TF implement skill. And if I were to just run this, it would discover that we have a specs folder that's full of prospective implementation. But I'll just give it a little helping information here. Implement plan. And issue. The specs and the local stats directory. So we're running the TF implement skill. That's the instructions in that are specified to look for specifications in a particular directory.
The one in IRE. Yeah. So the request that came in.
It's gonna reach out and reach out to our Git host here, which is a Git remote repo, and it's going to take a look at the issue that the TF plan workflow produced. It's going to verify that we have all the necessary prerequisites, and it's going to read those artifacts that were produced during the planning phase to actually go ahead and perform the implementation. And that's what we mean by spec-driven development. We have knowledge of what we want to produce. That was the prompt that I sent to the agent at the very top of the session. It created specifications, which are just artifacts that live in the repository that can be used to perform the implementation later on. So then we have a durable artifact of what we want to actually produce that the agent can then read and use later on. And you'll notice that I started a new session or a new, I cleared the context window of our agent between the specification and the implementation. And that was for a reason. If you've used these coding assistants before, you'll know that like once they fill up their context window, they go through auto compaction. And what auto compaction does is it takes the session history and it creates a summary from that session history, and it clears the context window and it places that summary right at the top of the new context window that it opens up. A lot of the times, if you're working on something that's not very complex, that's totally fine. But if you're working on anything with any moderate amount of complexity, that really leads to a drop in the output quality of what it's producing. But what you can do is you can circumvent that by just writing durable artifacts to the file system. And that's what we have here. We have a whole bunch of durable artifacts. You can then clear your context window manually, which is what I did, and then run a workflow that is expected to read those durable artifacts and produce whatever it's meant to produce. In this case, it's meant to produce Terraform code, and that's what it's doing. We're now using phase 2 of our implementation. Let's see here. Oh, it's creating task tracking. It's creating setup files. It's doing all the necessary setup. And then it's going to perform implementation here. You can see that we've already made changes to our actual Terraform files in the repository. It's writing the Terraform code that has been specified by our specs and our plan.md. It's using our modules version constraint syntax to pin versions to the latest minor version of our modules. downloading of private modules. It's doing Terraform init here. And because it's working agentically, you know, when it encounters an issue, it's smart enough to be able to work around it and understand what it needs to do. So we had a module provider, the provider that we had stubbed out in our AWS, in our Terraform.tf. It needed to be a certain version to, it needed to be over version 6 probably to support our, what was it, the SNS module that we're using for alarms. And so it updated the version of the AWS provider to meet that requirement. Terraform init was successful. It ran Terraform validate, and the configuration is valid. And it's marking off its work in the artifacts that it produced. So if we take a look at, where's task.md, this file, which we produced during the implementation phase, it's marking off, it's using a simple markdown checklist to mark off its work. Checking in our work and creating a commit. We're using pre-commit hooks here to make sure that all of our sort of standards are applied regarding tags and Terraform docs. And that makes it so that the agent must fulfill these standards to be able to get its changes into a PR. It tried to do a git commit, and those pre-commit hooks validated that the application tag was added to our resources. And because the agent hadn't implemented that yet, the pre-commit hook failed, and so the agent saw that and then added that application tag. All right, give it permission here. Okay, now it's going to go into a phase 3, which is design review. And that design review is meant to take a look at the produced Terraform code and use AWS Security Advisor and a code quality judge sub-agent to agentically look at the produced code and make sure that it passes muster with regards to AWS security and code quality.
So the security advisor, it's a part of the knowledge, AWS knowledge link, or that you are
Let's
kind of,
see. I think it's it's a custom sub-agent. Custom sub-agent that we've written.
And then the MCP server you hosted, say, for example, from enterprise fan in a way, right? The MCP, SCP, the HashiCorp MCP server is going to be kind of a bundled within Terraform Enterprise, or it is going to be separately hosted.
Yeah, so we're using a local MCP server here. So if you take a look at this .mcp.json in the root directory of the repository, we define 2 MCP servers here. The AWS Knowledge MCP server is a remote MCP server. It's just hosted on the internet at this particular domain. And that's because it's stateless. It doesn't actually perform any work. It just literally gives you information. And then we're running a local Terraform MCP server. And this is our Terraform MCP server is just hosted on Docker Hub. And so the command to run the Terraform MCP server is just docker run. And then here's our repo and tag. This is the latest one, I think, 040. Some important things here is that we've set the enable TF operations environment variable to true on this MCP server, so it's actually able to go out and perform changes on our Terraform tenant. By default, the Terraform MCP server operates in a read-only mode where it's not able to actually perform write operations on your Terraform tenant. This one we've set that environment variable to true, so it is able to perform writes, and you'll see that when it creates the. I believe it's going to create a workspace for this particular work. All right, so we've got a whole bunch more comments on our issue that the agent has opened up. We've moved on to the implementation phase, and right now we're in the design review phase. All right, wants to run our post issue progress shell script. So that shell script is just the one responsible for posting stuff to our issue. All right, we're now moving into phase 4, which is sandbox testing. All these phases are outlined by the skill that we ran, which is the TF implement skill. Requisites, implementation, design review, sandbox testing, report, and cleanup plus PR. All right. All right. So because we want to isolate changes from that the agent is introducing, and we want to test those in isolation, it's going to create a sandbox workspace in our HCP Terraform tenant. And it's going to test those changes in isolation and not necessarily mutate our existing if we had an existing workspace. And so if we go here to our Terraform tenant, you should be able to see it create this workspace for us. Let's look here. Whenever it does that. Actually, I think it creates it in a different project. So we'll just go to workspaces. Here is our workspace that it's under. Okay. There it is. Put it in the default project. All right, so it's created a sandbox workspace in our Terraform organization. It's just going to run a go ahead and run a plan for that. Make sure that the plan passes. And you can see it's going to it's telling the agent that it's a sandbox deployment for validation and proceed with applying after verifying the plan. This was the prompt provided to this TF deployer sub-agent. And I think I might have needed to set up my environment variables for AWS deployment. So this might actually fail, but we'll give it a look. Yeah, it did. Yeah, I didn't have any credential sources found. Let me see if I can do this. I'll have to go into my project. Okay, we'll do this. Do that open. Sure we get this back. Excuse me. I'm just providing credentials to actually deploy stuff on AWS, which is what we were missing. Okay. So I'm just going to tell Claude here I've set up AWS dynamic credentials on the sandbox space. You can attempt the plan again. And we'll see if that works. And that was just an issue with me setting up this demo. I just needed to have credentials in this default project where the sandbox workspace was created. So, Claude Code, VS Code Copilot, you interact with these things through natural language. So I just told it that I had added credentials to the workspace and to try the sandbox workspace that it created, and to attempt the plan and apply again. And fingers crossed this works this time. Okay. Let me see. Yeah, that should have worked. Interestingly, it reached out to the workspace and did notice that I had provided dynamic credentials set up. All right. Soon roll with web identity. Okay. All right, let's see if we can. I need to, set up the OIDC provider. I'll have to do that off screen to set up the OIDC provider for this particular HCP Terraform tenant. Or you know what? I can actually probably do that. just so we get this demo working. This shouldn't take too long. Okay. I believe need to go to organization settings. Here, let's try to do this. Let's go back to our demo workspace, our sandbox workspace. Yeah. What was the sandbox workspace? Here we go. Do this. And the role is this. Cancel, delete. Okay. All right, so I'll have to set up dynamic credentials on, I'll have to set up dynamic credentials separately. But that's the general workflow that the agentic workflow is going to use. It's going to use that separate spec-driven development workflow where we went through the TF plan and the TF implement. What I didn't get to show there was the creation of that sandbox workspace. Obviously, if I had my credentials set up correctly, that would have gone through, would have checked the sandbox workspace to make sure that the plan and apply had worked. And then it would have gone ahead and created a workspace for our repository if one didn't already exist. And then would have created a PR. Remember, we're using GitFlow, GitOps sort of development workflow where we start with an issue, then we create our changes, and then we open up a pull request against our default branch. And then that PR, because we have a workspace created against the repository, that PR would have started a speculative plan in our workspace, which we could have then accepted, seen that the apply was successful, and then merged that code into our default branch on the repository. So sorry about the little demo fail, but does anyone have any questions before we wrap up?
Quick question, and I know we are on time. First of all, do you share this recording after this meeting? And if you have PPT high level, that will be great. Thank you. Thanks for the nice demo, and thanks, Sharath, for arranging this. I had a quick question. So if one service, right, has right now, let's say, 10 different Terraform resources, how do you decide how many module we create, just single module or multiple module for all those 10 different sub-component, to function the overall service? How do you make the decision? Yeah.
That's a function of the what was it? It was during our TF plan phase or phase of the overall workflow where it took the specifications that it created, the spec.md and the checklist.md, and it created these module interfaces, this module interfaces.markdown file. And the way that it actually goes into deciding where, what resources are going to live in what module, that's just Claude code or VS Code. That's just their innate knowledge. We don't really apply any sort of like hard and fast rules around like what the actual module structure needs to be. It just uses its innate sort of intelligence to understand that. Now,
do we have option to? Does the customer has option to customize that?
Yeah, certainly. Yeah. So this is all just this is all just run by these markdown files that are using what we think are the best practices regarding creation of a Terraform module. So if you were to adopt this, you can customize these to your liking for sure.
Thanks.
Yeah. And again, and also, because the workflow is specified in these markdown files, you can stop the workflow at any time and just tell the agent to do something differently. That's the power of these agents, is that you interact with them through natural language. So if you see it doing something that you don't want it to do, you can just stop it and tell it to do something differently, and then it'll continue to try to within the bounds of the workflow that you're enforcing with these skills and these subagents and the scripts that they run. So if you want to enforce like some coding standards, or if you didn't like the way it created the modules and you wanted it to do something different, then after the plan phase, you could, but before the implementation phase, you could say, hey, I actually want you to split this module up. Can you do that for me? And it will, to the best of its ability, it will. All right. Anybody got anything else?
Thanks, Lee.
Yeah.
Okay.
Thank you.
Yeah. Thanks, Lee.
everybody.
Thanks
I'll
for
see if we can share the recording. I'm not 100% sure on that yet, but I definitely know we have a PowerPoint that we can share.
Yeah, please. Now, yeah, I think D needs to share that demo, D. But yeah, you can check internally and then send us that recording. Okay.
All right. Thanks, everybody. I appreciate your time.
Thank you. Thank you.
Bye.
Bye.